Hi everyone, my name is Anastasios Arima, but Taso for short. I am the Managing Director, CEO, and one of the co-founders of Hyperion Metals Limited. We are a company developing sustainable critical minerals and metals for the US, where we can. We want to be low to zero carbon. We believe we can be in all the minerals and metals we produce. We have secured a foundational asset in Tennessee, just west of Nashville, between Nashville and Memphis, which we believe will be one of the most significant titanium and rare earth containing deposits in the US and globally significant as well over time. We are then leveraging that deposit and combining it and integrating it with breakthrough technology, which was developed by the Department of Energy, with funding from the Department of Energy by Professor Zach Fang out of the University of Utah, and in conjunction with Boeing and Arconic, which can take those minerals or titanium metal scrap and produce very low cost titanium metal. With that, we want to reshore key critical minerals and metals, especially titanium metal and rare earths. We believe we can do this really well, and it would, if we do it, we create a lot of value. When we do it, we create a lot of value, and we are really excited about it. So that's a quick overview of what we're doing.
Good, man. Taso, lovely to see you again. Just let people know, you kind of came on to our private investment platform, educating some family offices about the world of titanium opportunities therein. And we're going to talk about one of them today with Hyperion. But I guess we better start off, people new to you and Hyperion, with a little bit of background about you. What's your story?
Yeah, absolutely. So I've been involved in the metals and mining space for 15 years. I started off on the financing side, although I have an engineering and business background. And then I was heavily involved in the fossil fuel industry, starting a few coal companies. We had a very successful coal company in one of the first coal booms from 2008 through 2011, where we sold out of that at about $1.2 billion valuation. And that started from a Starbucks in the middle of Calgary. That has now been built, went through ups and downs, but is now being built and is one of the largest export thermal coal mines here in North America. With current today's prices, making a lot of money. We then stayed in the fossil fuel industry for a few more years, and then I moved out. I moved to the United States and started an outpost in the United States for our group here. And once I moved to the United States, I realized I wanted to get out of the fossil fuel industry. And so my team and I, we redirected and started looking towards critical minerals and metals of the US. We started off founding a company called Piedmont Lithium, which eventually was called Piedmont Lithium. Again, started off with nothing, just an idea and a meeting in a Starbucks in North Carolina. I'm sitting in my Charlotte, North Carolina office today. And we moved that through from the 2016 period. We're able to hire an outstanding CEO who many of you have probably heard, Keith Phillips. And then we helped to build that up to what it is today. I recently stepped off the board 3 months ago now. But over the last 2 years, as the team became very strong in Southeast developments, the core team that founded Piedmont, we got together again and we decided, okay, what now should we tackle as critical mineral or critical metal issues within the US? We had learned a lot from Piedmont. We had learned a lot about developments. We had learned a lot about what industry needs as well and the downstream requirements for industry. So we wanted to tackle at that point titanium metal. So we've done this before. It's by no means we're going to be hugely successful again, but at the same time, we believe it will be.
Right. So you had your drop the mic moment with a contract with Tesla and then left. I like it. But what I get out of that is the importance of having a big idea, right? A big idea. So what's the big idea here with Hyperion? What do you see in front of you? What's the opportunity?
So Hyperion Metals is a little bit different than what we've seen historically in projects. Instead of being a part of the supply chain, with Hyperion Metals, we can be the complete supply chain. So Hyperion has the potential to be a complete monopoly in the supply of zero carbon, low cost, sustainable titanium metal, with the view that as we build out our operations, we actually gain a complete monopoly over those lightweight structural markets, which are dominated by, say, aluminum and stainless steels today. An example would be in stainless steel use and high-strength steel use in the electric vehicle battery industry. Titanium would be used, but has not been used because it is a expensive metal. It's also very carbon intensive. What we have with our technology is the ability to make it cheap. What we have with our deposit is the ability to integrate and supply as much of it as needed for American and eventually European industries. So it's a little bit different. In the other industries we've looked at, we've always been a participator. Strong. Piedmont, for instance, will be a major, in my opinion, a major lithium supplier in the industry. Fantastic company, fantastic management. Here with Hyperion Metals, we have the ability to be the global titanium metal supplier.
Okay, so let's break that down. So you got a deposit. People can look that up on your PowerPoint. I want to focus on the two aspects which could make the difference, which is the technology. I want you to explain what that is and what precisely you're talking about in terms of the market. Because stainless steel with the use of battery metals, what does that mean? Could mean a whole bunch of stuff. And I've seen some other applications mentioned in your press releases and also your presentations. So can we focus on the technology? What is it that you've got? Is it proprietary to you? Is it unique to you?
Yeah, so the technology is proprietary. It was developed by funding from Advanced Research Programs Agency within the Department of Energy. So similar to what DARPA is for the Department of Defense, ARPA is for the Department of Energy, set up by the Obama administration, funded heavily. Funds early stage critical research, taking it from laboratory to pilot scale. So there was approximately $7 million of funding that went to Professor Zach Fang out of the University of Utah, Professor of Metallurgy there, to investigate. He was did a lot of work in metal hydrides to investigate the low-cost development of titanium metal. Titanium metal has, for the last 70 years, been produced by one process, which is a carbon-intensive, energy-intensive process called the Crux process. People have tried new techniques but have failed. What Professor Zach Fang realized, or his scientific breakthrough that he had, was that there was a very elegant solution in that when you tried to reduce titanium minerals or titanium scrap with high oxygen content into titanium metals, and you did it in the presence of hydrogen, you could reduce it easily with any reductant. He chose magnesium because that's cheap. Prior to that, there was no ability. Thermodynamically, it was impossible to break the titanium-oxygen bonds and create a purified titanium metal just with reduction. So you had these heavily chemically intensive processes, being the Crux process, to produce titanium metal. That process he was funded. He got another $3 million between Department of Defense and Department of Energy grants, took it to pilot scale. He is producing titanium metal powders today at a small scale from the pilot labs, and showed that it was far lower energy intensity, far lower cost to make spherical powders to go into powder metallurgy applications and 3D printing, and it was all patented. So we are taking that on. We are expanding the research. We are looking to take it forward, but it is complete scientific breakthrough type research.
Okay, so does anyone come close to you? Is there anyone else out there that's got anything?
There's nothing. Everything else was focused around improvements really to the Crux process or electrolysis methods to make titanium metal. No one was able to hit the quality specs or the ability to scale like what we can.
Right, and you've got the zero carbon component, which you
sprinkle
lightly onto this.
Once you integrate with the backwards into the mineral deposit, you've got a lot more. But this technology as well can be used for zirconium metal production, and we're going to be testing it on other metal productions.
So let's park that up, because I want to keep this kind of fairly high level, big picture stuff, because you said big ideas matter here. So there's the technology. So in terms of the audience's application, more importantly, the current revenue potential of those revenue streams, those markets, versus what you think it could be, because what's it today and what do you think it could be?
Yeah, so the titanium metal market, if we look at just that metal market today, it's about $4 to $5 billion per annum. So it's a big market dominated by Chinese and Russian supply. That's the primary metal market, not the end parts. The end parts are a multiple of that once you take them through machine and mill. So that's an immediate market, which, especially here, the US is the largest market for titanium mill products, just because of aerospace and defense. So we believe that over time we will have that market, the US source supply of titanium over a Chinese Russian source. It's pretty easy to sell. But really where the big picture is in the substitution of mainly stainless steel, but also certain aluminum components. The reason we use stainless steel is for corrosion resistance. Titanium has superior corrosion resistance, as good or potentially superior strength, but is 45% lighter. So in almost all applications that you look to use high strength steels or stainless steels, you can replace with titanium once you bring the cost of titanium close to that.
How big's that market?
110 to 115 billion for stainless steel and growing substantially, and then 160 billion for the aluminum market. So realistically, it's a huge market.
That's getting interesting. So the USPs, so if you were selling into that market and you go, you should be using us instead of what you've been traditionally used to buying, because why? Remind me?
So lightweight. It's all the same characteristics, but it's lightweight, lighter weight, and more corrosion resistant. So that's the reason you're using stainless steel. So if you're using stainless steel in applications around corrosive environments, you should switch to titanium. That's really why you use a lot of stainless steel around the place. Stainless steel cooktops and, other like taps and stuff like that. You could do that, but really the big applications are those large industrial applications, those large applications within what is now the battery industry. We use a lot of stainless steel and high strength steels because you need corrosion resistance, you need high temperatures, you need high ultimate strengths, and you want lighter weight. Titanium wasn't an option before. Now that titanium will be an option with us scaling our technology, there's an opportunity to take that. And that's huge in the electric vehicle industry because weight, we look at cathode and the energy density as the numerator. The denominator is weight on energy intensity and range and everything. There's a lot being done on weight, but a 45% reduction in weight will do a lot more than an increase of 10% energy density. So it can enable not just passenger vehicles, but what we're seeing in some of the industry discussions we're having is that it could be a complete game changer for the freight industry, which is where batteries are not. It's
clear who you're going after. You've got a technology you're telling me is not only proprietary, but unique for now. You've raised $24 million recently in a private placement in Australia. What are you going to do with it to advance this story? But how do you advance this story?
So advancing the story is fairly straightforward. We've got what I would say is one, the mineral business, which is the mine and what we're doing in West Tennessee and the sustainability of mining around that, and then the metals business. So around the minerals business is the typical mineral development. We've got our JORC resource that that is imminent for the market. That's important because it establishes to the market and also to potential customers how that we have a major source of titanium minerals and rare earth minerals here. We then need to continue test work, scoping study, come out with that to identify how big it's going to be, costs, those sort of things, and then progress all the offtake discussions we have around the mineral products, whether it be the zircon, the titanium minerals, and the rare earth minerals as well, where we do have the relationship with Energy Fuels, where they could take it, crack it, and solve the rare earth supply chain. So that typical progression of mineral business development follows very similar progression as everybody else. The only thing I would say here is that there's a lot of interest, probably a lot more interest than a project in Africa or Australia, because these critical minerals in the US today are getting a hell of a lot of interest and having them. And in addition to that, we've got a very large focus on safety, sustainability of the system, decarbonisation of that mining, that minerals business. And we'll be making a lot of announcements over the next few months around how we are going to tackle that. So that's very important, adds a lot of value. If you put that to the side on the metal side of the business, where we are committing a large chunk of funding, approximately 10 million from the 24 million we raised. That is really optimization of the process that is happening today in Utah, optimizing it for both our ore that's going to be coming out of the ground in Tennessee, and then also the development, the titanium scrap to titanium metal production. There's a big focus by a lot of companies on a circular supply chain. This technology not only lowers the cost, but actually allows for 100% recyclable titanium metal, which was not possible with the Kroll process. So we are focusing on that, the optimization of that. And then as we head into next year, we are looking at scale up. So our first scale up facility to address the prototyping and potential small batch production for suppliers is going to be at least starting construction next year, and then post that over the longer term, we aim to commercialize that. But over the next, say, 12 months, it's optimization and then the construction of the first scale up facility as well.
Just listed, haven't you? When did you list?
We announced in September last year, and the transaction closed in December. I think December 1st, I was appointed on the board.
Very aggressive timeline.
The symbol TAO, and now it's HYM.
Yeah, they'll put it, that will indicate all of that. It's a very aggressive timeline. You're talking the language of someone who's trying to get this done really quick. Are you worried that you're going too fast, or are you worried about missing the
look, you got to
revolution?
There's growth plans when you go too far. For me, on the metals technology side, that's not too fast. This has been in development from 2013, 2017 through now. It's been piloted. There's some optimization to do specific to us, but I mean the process is known, and it's been repeated, and there's been tons of titanium metal made and sampled. So I don't think that's too fast. When I talk a scale up, I'm not talking 10,000, 100,000 tons. I'm talking, a scale up from where we are now. Still significant, but still not that 10,000 plus ton commercial. Now, potentially could be 1,000 tons. I don't know. We've got to do the work. But I don't think on the titanium metal side that's being too aggressive. I think we could be more aggressive, but we are talking to potential industry partners, and if we secure some of those for some early engagement with us, whether it be prototyping or small batch processing, then we will become aggressive, and you'll see what aggressive means on that. So, but on the titanium mineral side, that's where we're being a bit more aggressive than some of these other companies, and have been more aggressive in terms of exploration, land consolidation, moving through scoping pre-feas fees. We aim to finish our feasibility study by the end of next year. That is pretty aggressive. It's the timeline we believe we can meet, but it is aggressive.
Why do you think you can meet that? Because that really is quite quick.
The main reason is that instead of this is a mineral sands development, so it's relatively straightforward compared to, say, a lithium project development or a big copper project or nickel project. The minerals are separated through processes which are really well understood. So what we're doing there, usually with your pre-feas and fees on many projects, is about the metallurgy. So we're accelerating those metallurgical test work programs and trying to get them done we're going to have some more metallurgical results out this year. We'll try and have the very detailed metallurgical work done by the middle of next year. And that then feeds into the pre-feasibility and feasibility study. I think the pre-feas and feasibility study can be fairly straightforward because the mining's very straight. It's the simplest mining out. It's a sand pit, right? So it's not too difficult. And then the equipment needed is relatively well understood. And we are not, unlike projects in the middle of Australia or Africa, we don't need to design for supporting infrastructure. We just tap off existing grids, existing road and rail infrastructure for the development of the project. So there's no big long lead times on designing and engineering how you're going to get the product out, so on and so forth. So it's a fairly straightforward development. It's really getting that test work done, which has been what has delayed us this year. But that's why we're trying to do it faster into next year, and we believe we can hit those sort of timelines.
Okay, so if I look at your valuation, 160 million market cap, out of the gate practically, and you haven't done too much yet. You've got a whole bunch of things in place, but you've actually got to start doing things. The technology's there, I give you that. You've got a fair bit of work, you've got a bit of work to do on the actual deposit itself, but you've outlined feasibility study by end of next year. Fantastic. Do you think that people have made a rod for your back in terms of how they're valuing you today? Because how soon are you going to be able to come back and say, hey, we've got some MOUs in place, we've got some loose agreements in place with these industry players, and I think we're going to be able to work with.
Yeah, you bring up a good point. It's a bit different than a project that's $500 million in Africa or something like that, and financing is going to be an issue. Financing is no issue, in my opinion, for a project like this. We're not going to have those.
Tell me why.
There's high capital numbers we don't need. Capital typically for these mineral sands operations that you see globally are focused on infrastructure. Again, building ports and building rail is much more expensive than building work concentration plants, mineral separation plants, which are off-the-shelf technologies. So we've done a lot of work. We've spent probably $4 million to $5 million on the ground already in the last year on drilling and test work, maybe more. So we understand well that there's a deposit that's going to be globally significant and continue to grow out here. So I think people are starting to take that into account. Really, the size of it, I think if people understood the potential out here, that 160 million would be really cheap. So we need to continue to do that work, continue to get it out to market, and then then I think the value will come. I think from an MOU perspective, or a customer interaction perspective, it's similar. They can see that this will be a project. You have to take them through it, but they can see that. We've already sent a lot of customer samples out for both the zircon and the titanium minerals, and we've already secured at an MOU level the relationship with Energy Fuels, which is a strong relationship with Mark Chalmers and his team. So it's not as difficult as for a large pigment producer or a large ceramic company to say, will this be a real supplier that we can count into our supply chain? I think that ticks the box, and then it's really the discussion about, is it going to be a 2023 supply? Is it going to be a 2024 supply? Which a lot of the management teams there are looking at today. Now, I can't stress the advantage of being a US source of supply for US industries. There's huge advantages on logistics, on carbon intensity of those logistics. Our view is to be sustainable and decarbonize where we can. That helps them as well in their decarbonization goals. Everybody in the Western world, here in the US and eventually in Europe, and in Europe especially, are focused on that. So having lower cost, better logistics, better decarbonization within the supply chain is key. And we're probably one of the only development company that can offer that. So that's going to be, I think, a lot more straightforward than what people see it to be. Are
you going to have an OTC listing?
I think we do have an OTC listing under the bulletin board that we did not put it up. It's one of the ones where anybody can put it up, and it's not managed by the company. I think you have to go OTC QB or OTC QX, and then we have to report and all that. Now, in hindsight, maybe we should have done it at the start of the year. I've always been of the view, since doing it with Piedmont, that we want to get to a Nasdaq listing as soon as possible. And we still are pushing towards a Nasdaq listing. Now, the timing of that, we just need to see with a few things to do. But yeah, the Nasdaq listing is very important, and that's what I'm focused on. Do we do a QX in between? I think there's the potential to have the Nasdaq listing sooner rather than later. So there's no need to do the intermediary QX step.
Okay, fair enough. It's just obviously I think with the other thing I think you're benefiting from is the Tesla association via Piedmont previous operation, where perhaps you've got a ready and willing audience of Americans thinking let's more of the same, please, Taso. Okay, fine. So you've laid out the plan. You've got some money to do it. So what are we looking for next? What are the deliverables I can pick you up on if you don't deliver?
Yeah, so it's great. The milestones really are that the scoping study, the metallurgical test work programs, and the resource, of course, coming. And then there's further land acquisition and drilling that we've got being done in Tennessee. So that helps to continue to establish how big this critical mineral region is. So we're going to be getting that out. That's over the next 3 and 6 months. There's a lot of information to get out there, but it's a lot of value-added information, especially for the resource investor, which a lot of, I suspect, your base is. But in addition to that, then there's a lot to come out on the technology side. So we are having active discussions with a range of different parties on the technology side for potential prototyping. We have signed an MOU with EOS, the largest 3D printing machine maker, one of the largest globally, the largest in Germany. And we are going to be working more closely with them over the next few months as well to look at different opportunities to deploy titanium, low-cost, sustainable titanium metal powders within the system. But there's a lot of other discussions going on with machine makers, the groups that actually make the parts, the end users, and stakeholders that are involved in sustainable supply chains, both in Europe and the US. So there's a lot of information and potential relationships that we could announce in the future there, and that we're working on. But then especially there's a lot of milestones to come out on our actual test programs, work programs, taking the ore to metal, taking scrap to metal, what that looks like, how that compares against current titanium metals in the industry today. And we hope to get those results out so that we can show that, we can meet or exceed industry standards, and that it's just a matter of time before the world sees low-cost, sustainable titanium metal.
Taso, I appreciate you coming on, telling this story. It's sort of a young story, exciting space to be looking at. I love the subliminal advertising behind you. It's to the moon, folks.
Exactly.
This one's to the moon. Andy Warhol says so. Okay, appreciate you. Stay in touch. Let us know how you get on, okay?
Perfect. Thanks very much. See ya.